Let us now consider the product rule. Suppose that y is expressed as the product of two functions, fx being the first function and gx being the second function. So here is our first function, here is the second function. So y is the product of two functions. Then the derivative of y with respect to x can be written as the first function multiplied by the derivative of the second function plus the second function times the derivative of the first function. So differentiating product of two functions, we take the first function, then we multiply by the derivative of the second function, plus we take the second function, multiply that by the derivative of the first function to obtain the derivative of the whole product y. So let's consider an example. Y is a product of two functions. Here is the first function, and here is the second function. So y is a product of two functions. So to find dy dx, we could use the product rule. So we would write the first function and multiply that with the derivative of the second function. So derivative of x squared is 2x, derivative of x is 1, plus we take the second function, which is x squared plus x, and multiply that with the derivative of the first function. So the first derivative of the first function, if we differentiate 6x cubed, it will be 18x squared, the derivative of 6x cubed. Derivative of 5x is just 5. So the derivative of y with respect to x can be obtained by applying the product rule. This expression can be simplified by expanding the brackets and grouping the like terms, which is left as an exercise for you to complete. Let's look at another example. Here again, y is a product of two functions. This is the first function, which is marked in or colored in green, and this is a second function, which is colored in yellow. So y is the product of two functions, and we want to differentiate y with respect to x. We could use the product rule to differentiate y with respect to x. But before doing that, let's write y, or the right hand side of this equation, in a more convenient form. So the first function can be written as x plus the 1 on x, or rather 2 on x can be written as 2 x raised to the power minus 1, because 2 on x is in fractional form. We can write 2 on x in a non-fractional form by taking x from the denominator, take it up to the numerator. We would reverse, we would negate the index. So the index of x is 1. When you negate it, we have x to the minus 1. The second function is in non-fractional form, so we will leave it as it is. So now we have written y in a more convenient form, and we can apply the product rule. So product rule states it's the first function, which is x plus 2 x raised to the power minus 1, multiplied by the derivative of the second function. So the derivative of second function, the one in yellow, x cubed, the derivative of x cubed is 3x squared, derivative of x to the 4 is 4x cubed, plus the second function, which is x cubed plus x to the 4 times the derivative of the first function. Derivative of x is 1. The derivative of 2x raised to the power minus 1 is minus 2x raised to the power minus 2. So here again we have applied the product rule to find the derivative of y with respect to x. This term on the right hand side can be further simplified by expanding the brackets and grouping the like terms, which is left as an exercise for you to complete. Let's look at another example, example 11. Again here, y is a product of two functions. So here is the first function in green. Here is the second function in green. So we multiply two functions to express y is expressed as a product of two functions. So differentiating y with respect to x, we could apply the product rule, but we will write y in a more convenient form, so which doesn't involve fractions. So we could write the first function as 6x raised to the power minus 3 plus 5x raised to the power minus 1. 5 on x is 5x raised to the power minus 1. And the second term, we have x squared plus 1 on x can be written as x raised to the power minus 1. Now we can apply the product rule. So it is the first function, which is 6x to the minus 3 plus 5x raised to the power minus 1 times the derivative of the second function. Derivative of x squared is 2x. Derivative of x raised to the power minus 1 is minus x raised to the power minus 2 plus the second function times the derivative of the first function. So derivative of x, 6x raised to the power minus 3, we will drop the minus 3 to the front, so you'll have minus 18. Minus 3 times 6 is minus 18 x. Subtract 1 from minus 3, so you have minus 4. Derivative of 5x to the minus 1 is minus 5x raised to the power minus 2. So here we have applied the product rule to obtain the derivative of y with respect to x. Again, this expression on the right hand side can be simplified if we expand the brackets and group the like terms, which is left as an exercise for you to complete. Example 12. Again we have y expressed as a product of two functions. This is function 1 marked in green, function 2 marked in or colored in yellow. So we could write the derivative of y with respect to x by applying the product rule. So we take the first function, which is the one that is colored in green. It's the first function multiplied by the derivative of the second function. Derivative of x cubed is 3x squared. Derivative of x raised to the power 4 is 4x cubed. So that's the first function times the derivative of the second function plus the second function, which is x cubed plus x raised to the power 4 times the derivative of the first function, which is a derivative of x raised to the power minus 2 is minus 2x raised to the power minus 3. Derivative of x raised to the power minus 3 is, well, derivative of 2x raised to the power minus 3 is minus 6x raised to the power minus 4. So again we have applied the product rule to find the derivative of y with respect to x, and the expression on the right hand side can be simplified by expanding the brackets and then grouping the like terms, which is left as an exercise for you to complete. Here is another example. Y is expressed as a product of two functions. Function 1 is colored in yellow, colored in green. Function 2 is colored in yellow. So we want to find the derivative of y with respect to x. We can use the product rule. It's the first function, x squared plus 6x to the 4 times the derivative of the second function. Derivative of 3 is 0. Derivative of x squared is 2x, plus the second function, multiply that by the derivative of the first function. Derivative of x squared is 2x. Derivative of 6x raised to the power 4 is 24x cubed. Again, we can simplify the right hand side of this equation by expanding the brackets, which is left as an exercise for you to do.